Hello everyone, my name is Kanika Jalonwong from the Faculty of Engineering at Chiang Mai University. And today I am pleased to present my research topic, Health Risk Map related to particulate matter exposure in Chiang Mai, Thailand. In this presentation, I will start with the research background, followed by the objective, methodology, results, and my final conclusion. Let's start with our research background. Chiang Mai is a province located in the north of Thailand. Chiang Mai citizen has been facing pollution problem for many years already. As you can see on the graph of average PM2.5 concentration in 2017 to 2020, especially during January to April, the level of PM2.5 is the highest and far exceeding the standard level of 10 microgram per cubic meter as recommended by WHO. Exposure to PM2.5 this high can severely affect human health, which increase the chance of developing the disease such as dermatitis, chronic rhinitis, bronchitis, or stroke. These are just a few examples on human impact from exposure to the pollution. Moreover, the number of hospital admissions caused by PM2.5 reached to 20,000 in January to March, is leading to negative consequences. The problem that follow occur in the public health service is insufficient public health service due to a shortage of medicine, insufficient admission to the hospital beds, or medical equipment. Because there's only 200 physicians in the public hospital and only 2,000 beds to accommodate the patients, the situation was not adequate for the rapidly growing number of the patients throughout that time. From the pollution problems, we would like to find out the risk area of Chiang Mai, and it would be a guideline to develop pollution plan or point out the priority area for preventing and handling any pollution problems that will arise. Therefore, it would be the objective of this research. First one is to estimate the risk area of human health impact due to exposure to PM2.5 in Chiang Mai as a Chiang Mai risk map. Second one is to estimate the relationship of population exposure to PM2.5 and human health effect. In this study, we focus on 25 districts in Chiang Mai province in January to April 2021 because this is the peak period of pollution in Chiang Mai in every year. We collect the actual data of PM2.5 concentration from 62 ground-based monitoring sites that's called dashboard. Dashboard is a low-cost sensor located in many areas throughout Chiang Mai and predict the data of PM2.5 in a real time. The number of hospital admissions due to the impact of PM2.5 was collected from Chiang Mai Provincial Public Health, and the data of population and area of Chiang Mai was collected from the National Statistical Office of Thailand. This is the methodology of this research. We divided into 3 stages. The first stage is the analysis of the distribution of PM2.5 concentration. The second stage is the analysis of distribution of population exposure to PM2.5, and the last stage is the analysis of the relation of PM2.5 concentration, population, and population exposure to PM2.5. This is the first stage. We collect the PM2.5 data from ground-based monitoring station called dashboard. We start with checking PM2.5 data from daily to monthly and calculate the weighted mean of PM2.5 in each district, and then presented in the map of distribution of monthly average PM2.5. The next stage is to estimate the spatial distribution of human health effects due to PM2.5 exposure. In each stage or in each district has a different population density and difference of PM2.5 concentration. So we adjust the data by calculating the population weighted mean or population exposure to PM2.5. We use the data of monthly average PM2.5 from the previous stage and determine the health impact of PM2.5 from the number of hospital admissions due to exposure to particulate matter based on ICD-10 disease. Then the population weighted mean of the population exposure to PM2.5 is equal to summation of psi I divided by the total population, where psi I is the population exposure multiplied by the particulate concentration of location I. We then display the results in the map by using ArcGIS application. Lastly, we estimate the relation between PM2.5 concentration, population, and population exposure by using a correlation coefficient, meaning of the correlation coefficient value equal to 1 indicates a strong positive relationship, and -1 indicates a strong negative relationship, and 0 indicates no relationship. The results of this research is as follows. There are a differential map of the monthly average PM2.5 concentration in each district of Chiang Mai in the period January to April in this year. The color in the map indicated the risk pollution area, with the red color is the highest level of monthly average PM2.5 concentration, followed by orange, yellow, green, and blue. In the risk map of 4 months, you will see the high pollution area were in the center and the north of Chiang Mai. March was the worst month by far for the good air quality, with almost area of March were covered with the red color. Moreover, PM2.5 level increased from January to March because of the open burning season in the agricultural life cycle of Chiang Mai, the trans-boundary pollution from nearby country, and the geography of Chiang Mai, which is surrounded by the high mountains. And PM2.5 level was down in April compared to the previous 3 months because of the coming of the rain season. The spatial distribution map in Chiang Mai risk map is clearly show the periods and the area of high exposure to PM2.5 concentration, and also show the highest health impact area of Chiang Mai, as presented in the following slide. In this section, you can see the spatial distribution map of human health impact due to exposure to PM2.5. The color indicates the human health effect, with the highest impact area indicated with red color followed by orange, yellow, green, and blue respectively. The effects of the human health risk area can be noticed from the map, that the highest impact area was in the center of Chiang Mai. In January, February, and March, Mueang District was the highest health risk area with the highest hospitalization due to exposure to PM2.5. There were 38, 34, and 43 hospitalizations in a square kilometer from January to March respectively. In April, the highest risk area were in Merim and Sanpatong district, with the number of hospitalization in a square kilometer equal to 8 and 6 respectively. However, it was lower than the previous 3 months. The highest PM2.5 concentration was in the north of the Chiang Mai, but the number of hospitalizations was low. It consists of the density of the population in each district. The population that live in the urban area less than the center area. That is the reason why human impact in the center was higher than the other area. Furthermore, the hospitalization trend increased from January to March and decreased in April. It is the same as the trend of average PM2.5 level in the previous slide. It is related to the results of the correlation analysis as the next slide. This is a result of estimation of the relation between PM2.5 concentration, population, and population exposure by using correlation coefficient analysis. The PM2.5 concentration was highly related to population exposure to PM2.5, with the value of correlation coefficients equal to 0.71. It means that when PM2.5 concentration increase, it leads to an increase in health effects, such as the number of hospital admissions. On the other hand, the number of the population is not influencing the PM2.5 concentration. In addition, we illustrate the human health impact data collection. This chart presents the number of hospitalizations in all causes of disease during January to April in 2021 in Chiang Mai. We got the ranks of the number of hospitalizations in each disease attributable to pollution. The top 4 ranks disease of 4 months were dermatitis, chronic obstructive pulmonary disease, conjunctivitis disease, and cerebrovascular disease. This chart will notify that the population in Chiang Mai has a high chance of getting this disease when exposure to pollution. Now we are moving to the conclusion of this study. In this study, we got the Chiang Mai risk map that demonstrates the risk area of PM2.5 and show the human health impact area due to exposure to PM2.5 and the relationship between PM2.5 concentration and population exposure to PM2.5. And lastly, the results should be useful to point out the priority area for Chiang Mai Public Health or local decision unit in pollution prevention plans, such as sufficient distribution of air filter or face mask for hospital patients or sensitive groups, or arrangement of that field room in the most risk area first to help rise of awareness. And it will be a guideline in practice for decision-making in policy that should be reflect the difference of existing health risks. That brings to the end of my presentation. Thank you for your kind attention.